everyone, it's time for lesson 12.5, scatter plots and lines of fit. This is Mrs. Trombley coming at you live from my basement. A scatter plot. Alright, I think you've seen these before. It's a graph that shows a relationship between two data sets. The two data sets are graphed as ordered pairs on a coordinate plane. So with these, a scatter plot, we're not connecting the dots at all. It's just a bunch of ordered pairs. And there's some different relationships that you need to notice about them, how the data are related, or the correlation of the data. That's a word you'll be hearing a lot in class. All right, if you look at all of the dots on a scatter plot, and you see that they're going up, so as x is increasing, this is my x-axis, y is increasing too, that means there's a positive relationship or positive correlation. If you see that as x is increasing, y is decreasing. So here's x right up here. As x goes up, y goes down. That means that there's a negative relationship or a negative correlation. If you're having a hard time telling, I usually would just kind of draw a line through and see, does it look like these values are going up? Positive. Does it look like these values are going down? Negative. There's also a time when there is no relationship. We are never, ever, ever getting back together. So when you look at these, they're just kind of everywhere, all over the place. There's not a pattern. That means there's no correlation between x and y. Whatever x is, whatever y is, there's no relationship, there's no correlation. So let's try it. Take a look at these dots and see, is it positive, negative, or none? Here, if I draw a line kind of through where the data is heading, I see that as x is going up, y is going up. That means positive, so write positive. Here, I don't know, they're kind of, I mean, if I drew a line, I'd have points that were really far away from it. They kind of don't wrap around the line. So this data is looking like all over the place. So we're going to say none. There's no correlation. And last, if I drew a line through this, most of them are to the right or to the left or to that line. I would say that because as x is increasing, y is decreasing, this is negative. Wouldn't it be nice if that was the end of this? No, it's not. Let's apply this. Turn your page. We're going to apply this and actually link it back to linear, because everything links back to linear functions, doesn't it? Is that what you're finding this year? Okay, so line of fit is a phrase that you're going to hear. A line of fit is a line drawn on a scatter plot close to most of the data points, which we just did on the front. We kind of just did that determining, is it positive, negative, or none. So this line of fit that we draw, it can be used to estimate data on a graph. So it lets us see the patterns and estimate more of what we can't see on the graph. All you have to do to figure out the line of best fit, or line of fit, is draw a line through the data value that's close to most of the points. That sounds easy so far, right? Then you're going to choose 2 points on the line and use them to find the slope. Do you remember 2 points on a line, how to find the slope? y2 minus y1 over x2 minus x1. Maybe we should write that right here. y2 minus y1 over x2 minus x1. Alright, so that'll give us our m. Then we're going to locate the y-intercept. Remember, that's your b. And we'll plug them into y equals mx plus b. Because if we're drawing a line on a graph, that means it's linear, and that means y equals mx plus b. So we're not going to have a perfectly straight line. We're going to have a line of fit, or a line of best fit. We can come pretty close to estimating what the data will be. So let's try it. I give you a data table here, and it says months and money owed. And thank goodness the money owed is going down every single month. I'm glad it's not going up. So this shows how you're paying off a credit card bill over a series of 5 months. So what you're going to do right now is I want you to plot these ordered pairs on your graph. Remember that if x is 1 and y is 1200, that means the graph looks like this. So on the other side, I'll kind of scooch back and forth here. Let's label our x-axis, and it says that the x, that's months, and the y is the money owed. And that's in dollars. Money owed in dollars. Now we need some numbers. And when I look at the values in the table for the x, it's just 1, 2, 3, 4, 5. And I definitely have enough space to count by ones. So I'm going to number this 0, 1, 2, 3, 4, 5. And I'm going to keep going because it bothers me if I have empty spots. It just doesn't seem right. Okay, y-axis, a little bit different of a story. My highest value is 1200. My lowest value is 410. I'm thinking if we're going from 400 to 1200, I know you could put a break. I'm not going to use a break. I'm just going to count how many lines I have. I have 1, 2, 3, 4, 5, 6, about 7 lines that I'm going to want to use. I don't want to write over top of that. And if I have to get to 1400 using 7 lines, 1400 divided by 7 is 200. So I'm going to count by 200s. You should too. Again, if you wanted to use a break, you could. I'm not going to for this one. Okay, now we're going to plot these data points, and I don't want you to connect the dots as you go. Let's just make it as a scatter plot. So again, I'm looking at these as ordered pairs. My first ordered pair is 1, 1200, so I'm going to go over 1 and up to 1200. Plot your second ordered pair. It's 2, 1000. 3 is 850, so here's 600, here's 800. This would be 900, so 850 would be right about there. 4 is 600, and 5 is 410, which I'll put just above that. Now, this isn't going to be a perfectly straight line, but it's going to look really close to it. So our next step, we just plotted all those points, is to draw a line through the data that's close to most of the points. If you don't have a ruler, you're going to want one. Hit pause. I'll be waiting for you. Welcome back. Alright, so I'm going to just draw a line through these points that goes through most of them perfectly. And I'm going to go make sure I touch the x and y axis when I draw my line. So my line looks a little something like that. Hopefully yours does too. So that was step 1. Draw a line, other than plotting our points. Okay. Now what we're supposed to do is we're supposed to write an equation for the line of fit. To write an equation of a line, we need its slope and we need a y-intercept. Well, in looking at this, it seems like the y-intercept is pretty easy to locate. What do you think? I mean, look at the y-axis here. It looks to me like it's touching the y-axis at 1400. So I'm just going to write up here for my own self and for you that the b is 1400. Now I need the slope, right? And to find the slope, I just need 2 ordered pairs from this line. So let's look at our table. What ordered pairs would you like to use? It doesn't really matter. I like these numbers, so I think I'm just going to choose the first and second point. Why not? It doesn't matter. So my ordered pairs that I'm using, I think I'll list them out so you know where all this stuff is coming from. To find the slope, I am going to use the 1 and 1200 point and the 2 and 1000 point. Let me see if you can see all this. Yes, you can. Okay, so slope. Take y2 minus y1. So y2 minus, y1 divided by x2 minus x1. This isn't making sense. Remember that we have our first ordered pair, x1, y1, our second ordered pair, x2, y2. And I just chose those 2 points because I did. You could pick any points that you want. Okay, so 1000 minus 1200 is negative 200, and 2 minus 1 is 1. So it looks to me like the slope would be negative 200. It makes sense that it's a negative 200 because aren't the values going down in this? And if you have a line that's decreasing, that means negative slope. So now we know our m and we know our b. So an equation for the line of fit would be y equals negative 200x plus 1400. So that would mean that this starts at 1400 and every month we're going down by about 200. And if you look at your data table here, from here to here it's down by about 200. From 1000 to 850 it's not exactly, but it's close. 850 to 600, about 200. 600 to 410, it's about 200. So when we're looking for a line of fit, we use that word about a lot because it's not exact. It's about. Okay, and this is why we're doing this, to be able to answer a question like this. It says to predict the amount of money you will owe in 6 months. So that's not on your graph. Well, I guess we could follow it up and use it on your graph, but let's say I said 12 months or something greater than that. I want to give you the general idea of how to do this. So if we want to predict how much money we'll owe in 6 months, you remember that the months are your x, right? So in my equation, if I want to know 6 months, I'm going to plug 6 in for x. So we have our equation y equals negative 200x plus 1400. All I need to do is replace x with 600, and we can figure out how much we'll owe. So I'm going to plug a 6 in for that. If you take negative 200 times 600, that is negative 1200. Negative 1200 plus 1400 gives us 200. So in 6 months, we'll only owe about $200. And then the following month, guess what? I bet you'll have it all paid off. I will see you tomorrow.